Welcome to the practice video for dependent samples t-test. Here we see the data set up in SPSS. It's identical to what we saw in Excel. So we have 555 for the first person on their first time, 563 for that first person on their second time. That's in the data view. If you click on this tab at the bottom left that says variable view, we can then specify things. So if you didn't want it to say SAT1, you wanted it to say SAT T1, you could make that change here. You could also do SAT pre and SAT post. Again, either one of those would be correct and appropriate. I've set my decimals to 0. You can either click on that or you can just type in the number by highlighting it, because with SAT scores, they are integers, so they go from 541 to 542. You can't have 541.2 or anything like that. And then I've set my scale of measurement to be scale because we are working with interval or ordinal data. With SAT scores, it's really interval data, but importantly, it's continuous, and SPSS notes that as scale. I could do a graph to check normality, so I could go in here, go to histogram. Now, if I do normality, I can do normality with my original scores. The problem with that is the assumptions in a dependent samples t-test is about different scores. So I'm going to click cancel. I'm going to go back, and I can go into transform and compute a new variable. So I'm going to compute a different score. I'm going to call it diff pre-post. And that difference is simply going to be the pre minus post. Easy peasy. Click OK. The output tells me what it did. This is now consistent, and if I flip back to Excel, you can see -8, -1, +1, -3. These numbers are consistent with those. I'm going to go into variable view. I see that it's given me 2 decimal places. Again, I can't really have decimal places. I'm going to remove them. And now that I have this new variable, I can go into graphs, start this again, go down to histogram, and now I can do a histogram with the different scores, which is what the assumption is based on. I'm going to plot a normal curve on top of it. This will allow me to more quickly and easily see, are these different scores normally distributed? And we see relatively normal. Again, we could check skewness kurtosis to formally get a quantitative assessment of that. I've already done that in a previous video, so I'm not going to do that for the moment. Once we check our assumptions, we can then go into Analyze, go into Compare Means, and we are doing a paired samples t-test. I can do this by moving them over. So I could put pre in, put post in, I can drag and drop. If you're more comfortable with arrows, you can also do it that way, where you highlight it, use the arrow to move it over. Under options, I've changed my confidence interval to 90%. The reason being that we are doing a one-tail test. Well, if I tell it to do 95% confidence, SPSS defaults to a two-tail test. So what it does is it splits that 5%. So I end up with 2.5% at the top, 2.5% at the bottom of that confidence interval around the mean difference. However, I want 5% because my T critical is based on a one-tailed test. So if I take 90%, that's going to give me 10%. SPSS, because it's doing two-tailed, splits it, so I end up with 5% at the top, 5% at the bottom. So this should make it so that my upper and lower limit will match what we just did in Excel. So I'm going to click continue, then I'm going to click OK. I'm going to expand this just a little bit, make the font a little larger, just to ensure that everybody can read it in the video. So looking at this, we see the mean, the standard deviation. We have not calculated those for each of our groups. When you are reporting a dependent samples t-test, you often do report the mean at time 1, the mean at time 2. Of course, you're familiar with how to do the mean and the standard deviation, so you could calculate those. What we have calculated, though, is everything down here. So our mean, negative 2.5, that is consistent with what we saw in Excel, where our mean was negative 2.5. Standard deviation of the difference was 2.8618. Here we see 2.862. It's rounding to 3 decimal places, but it's giving us the same values. Standard error of the mean difference. And then if we look at the lower and upper limit, like I said, we have adjusted this so that it's giving us 5% at the top, 5% at the bottom, because our T critical is based on a 1-tel test. It's giving us 5% at 1-tel. So if we look, this is negative 3.388 for the lower limit. We got negative 3.877. And so that's when rounding, right? Negative 3.388. So it's going to be the same. Upper limit, negative 1.6123. Well, we know it is rounding to 3 decimal places. 3 is less than 5. So it's going to end up negative 1.612. And if we look here, we get the same thing. T is going to be negative 4.785. It's consistent with the T value that we got for T obtained, right? So negative 4.7848 is going to round to negative 4.785 because 8 is more than 5. And we see the significance level. With this significance level, this is 2-tel significance, so we would have to ultimately change it to 1-tel by dividing by 2. Importantly, if your original value is less than 0.001 and you're going from 2-tel to 1-tel, whatever your end value is going to be even less than what the original value was. So we can click in, see what the exact value is, and we could then divide this. But on some level, we already know that it's going to be less than 0.001. And so we can simply report this as less than 0.001. And then we can change this to be 1-tel. So that later, if we're looking at this, we remember, okay, I did go and I already calculated the p-value as 1-tel. So it was originally 2-tel. Now we know what that value is for the 1-tel value. That gives you an introduction to how to do paired samples, dependent samples, t-test in Excel and in SPSS. If you have questions, feel free to put them on the Q&A board.